Hi, welcome back to Technicamp's Introduction to Programming for Teachers, all done in Python. This session continues from session 6, which is about loops. We're continuing with loops today. The focus of today is going to be in applications, so something called processing sentinels, as well as something called, as well as dealing with common loop algorithms. So processing a sentinel value. Sentinel values are often used when you don't know how many characters or how many items are in a list. You use a special character or value to signal that there are no more items, right? You've reached the end. We're using a sentinel value to indicate that we've reached the end of something. For numerical input of positive numbers, it's quite common to use the value -1. So if we were getting a user to enter positive numbers over and over and over and over again, to indicate that they were finished, we might use a sentinel value of -1, because -1 is not a positive number. And that kind of indicates that we've reached the end of all the inputs that we wanted. Okay, so in this nice little yellow box, a sentinel value denotes the end of a data set, but is not part of the data set. Okay, so if we're thinking about positive numbers, we're using the value -1 as our sentinel value, because -1 is not a positive number. It's not part of the data set. Okay, so in this example, in this grey box, we set our salary to 0. While salary is greater than or equal to 0, salary equals float input. If salary is greater than or equal to 0.0, total equals total plus salary, count equals count plus 1. Our sentinel value here is our salary, and if our salary ever gets below 0, so if ever the user enters something less than 0, something like -1, this while condition, this salary greater than or equal to 0, is going to become false, and we'll exit the while loop. Okay, so we can use a sentinel value here as a way of exiting our loop. Okay, indicating that we've reached the end of the input data that we were having, and stop. Okay, so if we were trying to do something like averaging a set of values, we'd need to do a couple of things. So this is kind of a task for us to do. We're going to average a set of inputted values. We're going to declare and initialize a total variable, and we're going to set that to 0. We're going to declare and initialize a count variable and set that to 0. So the total is going to keep track of our total. The count is going to keep track of how many entries we've had, because we're going to need those to work out the average. And then we're going to declare and initialize a salary variable and set that to 0. Okay, then we're going to prompt the user with some instructions. We're going to have a loop, and we're going to keep looping until the sentinel value is entered. And the variable we're going to use for our sentinel value is salary. So save the entered value to an input variable called salary. If the salary is not -1 or less, so here's our sentinel value, we add the salary to our total variable, and we increase the count variable by 1. Okay, so our total variable is going to have it's the inputted salary added to it over and over and over again, keeping a running track of our overall total. The count variable is going to keep track of how many times we've entered a new value. And then we're using the salary as the way of entering data, and it's our sentinel value. If it's -1, we're going to exit the loop. The last thing, pretty much the last thing we have to do is make sure that we've actually entered at least one entry. If you're looking at the average of a set of values and they don't give you any information, you might do an accidental division by 0, and your computer will throw an error. But provided they've entered at least one entry, we do the averaging step, which is to divide the total value that's been inputted and summed up. We're going to divide that by the number of values that have been submitted, so that's going to be stored in the count, and we're going to output that value. Okay, so as a Python program, this is something that you might want to pause the video and copy down, but I'm going to read through it. We're going to initialize our variables to maintain the running total and the count. So the total is, our overall value, the thing that we're constantly summing up, and our count is the number of entries that we've been given. So this happens outside the while loop. We are going to declare and initialize our variables for use. Okay, we're going to initialize our salary to a non-sentinel value. So we're going to initialize salary to 0, so that the while loop will be executed at least once. Okay, because our salary is equal to 0.0, 0.0 is greater than or equal to 0.0, and we enter the loop. Okay, We then get the user to input a salary value. So salary equals float, input, enter a salary, or -1 to finish. Okay, so this -1 to finish is our sentinel. We do our comparison here to check if we've entered a value that we want to sum up, or if they've entered a sentinel value. So if salary is greater than or equal to 0, so if they've not entered the sentinel value of -1 or less than 0, basically, we increase our total by the amount that they've just input, the user has just input, and we increment our count to keep track of the number of times the user has submitted a value. Okay. Because for us to enter this if statement, our salary value must be positive, and then we'd loop back to the start, and hey, our salary value is positive, so we can ask them for a new salary value. If the salary value is -1, the sentinel value, the if statement doesn't run. We loop back to the start of our while loop. Salary is set to -1. -1 is not greater than or equal to 0.0, so we exit the while loop and move on to the next step of our program. The next step of our program is to make sure that we've entered at least one number to prevent a divide by 0. So if count is greater than 0, i.e. the user has entered at least one value, the average is our running total divided by the number of inputs the user has given us, so total divided by count, and then we're going to print out the average salary is followed by the value stored in the variable average. Else, so if the value of count is not greater than 0, then that means the user hasn't entered any data at all, and we're going to print out no data was entered, and this will allow us to avoid or prevent this divide by 0 error. Okay, so if we were to run this program, enter a salary or -1 to finish would be printed to the screen, and we say enter 10. That's positive, so that gets added to our running total, and our count increases by 1. We loop back to the start of our loop. The value that we just entered, which was 10, is greater than 0, so we again ask, hey, please enter a new salary, enter 20, and this continues. Maybe run through this through by hand using one of those trace tables that we talked about in the last session. And eventually the user enters a value of -1. -1 is not included in the total, right? It doesn't get added to the total. So we take the average of 1, 2, 3, 4, 5. So we sum up these 5 values, 10 plus 20 plus 24 plus 23 plus 12, and then divide that by 1, 2, 3, 4, 5. Okay, this -1, this sentinel value, is giving us an indication of when to exit the loop. It is not part of the data set. Okay, so pause the video. You might have to rewind it a little bit, but pause the video and copy down this entire program. Maybe you can call it sentinel.py. Okay, and then run it with the value specified here and make sure that it outputs the right value of 17.8. If you want to really, really make sure you understand this program, break out a piece of paper and a pencil, start writing a trace table, keep track of things like what is stored in total, what is stored in count, what is stored in salary, get your paperclip out and move your paperclip, up and down through the loop to make sure you do it line by line. Have an average that you keep track of, and so on. Okay. Some programmers don't like the trick of initializing the input variable with a value other than a sentinel. Okay, so what we did in our program is we set salary to 0 to ensure that it actually entered the loop at least once, right? It definitely gets into the loop and then does some follow-up code. An alternative approach to this is to actually set the variable with a read before we enter the loop. So this is a different way of approaching the problem. We're not going to guarantee that we enter the loop. We're just going to get the user to input their first value straight away. Okay, so salary equals float, input, enter a salary or -1 to finish. If they don't enter a positive number here, we're never going to enter this while loop. Okay, so they could just enter -1 straight away, in which case they've not added up any numbers at all. Okay, this is maybe something that some programmers like doing and some programmers don't. I quite like this, but sometimes I do this as well. Okay, I do switch between the two. Okay. So because we've taken our input at the start, we know we only enter the while loop if the input was greater than or equal to 0. So we can do the total plus salary step and the count equals count plus 1 step straight away without having to do this if statement that we had in our previous set of code. And then at the very bottom of our loop, we can do salary equals float input, enter a salary or -1 to finish. Okay, so we've actually managed to rewrite our, by taking this priming read at the start, we've actually managed to rewrite the code inside our loop, inside our while loop, to not include this if statement. It's also rearranged the program slightly, so the salary is read at the bottom rather than at the top. So if you kind of maybe pause the video again, have a little look at this, and compare it to this version, right? This is the other version. Okay, you can see that in this one I had to take the read inside the loop at the top of the loop, and then I had an if statement to check. In this new updated version where I do a priming read, I do the priming read outside, and then I have no if statement inside my while loop. Okay. Another way that people do things is using Boolean variables. So you remember we talked about Boolean values being like flags. They're either up or down, true or false, 1 or 0. We can do that. We can use a Boolean value to control our loop. So we could create a Boolean variable called done and assign it the value false. Okay, this is done, so it's initialized so that the loop will execute the first time. So while not done, well, the value in done is false, not false is true. So while true, it enters the loop, value equals float, so we take our input here. If they enter the Sentinel value of -1 or anything less than 0, we set done to true. Okay, we flip the flag from up to down or down to up. And we skip the actual processing because we've entered a Sentinel value, and a Sentinel value isn't part of the data set. Else, go and run the code that you normally would have run. Okay. Because done, let's say we entered -1, because done is now set to true, the if statement's run, we jump back to the start of the loop, not done, well done is now true, so not true is false, and that comes out as false, so while false, so the while loop will exit, and we'll move on to the rest of the code. Okay, whatever would be down here in line with the while loop. Okay, so that is a little bit complicated. It might be worth pausing the video and writing out the programs in kind of each way. So write out the program where we don't prime the initial value. We don't do a prime read or priming read. Then write out the program where we do use a priming read, right? This version. And then maybe write out the program where we use a Boolean value as well. Okay, so we use a Boolean flag rather than, well, as part of our program. Okay. Now, there are lots of different reasons to use loops. So we're going to go through about 5 different really, really common places where loops are used, or loop algorithms are used. So the first one is going to be summing things up and taking averages, which we looked at. It was almost the first part of this session. The second one is going to be about counting matches, so making sure, counting the number of times something happens that we're specifically looking for. Part 3, or example 3, would be prompting until a match is found, so repeatedly checking some data set or some input until we actually find a match, if there is a match. Example 4 would be finding maximums or minimums of a data set, and then part 5 would be comparing adjacent values. Okay, so let's say we wanted to look at sum and average. That example first. So we're going to do sum the values first, which is this top line, this top box. We initialize a total outside our while loop to 0. Okay, this is going to be our running total. And then we're going to do a priming read. We're going to ask the user to enter a value. Okay, whilst the input value, or the input string, is not the empty string, so that's going to be our Sentinel value. If they enter the empty string, we finish, we exit the loop. So while the input string is not the empty string, convert the input string into a float and store it in something called value, add this value to the current total, and store that new value in total, right? So keep a running track of the total, do a summation, and then ask for another input. Okay, and then this loops back to the start of the while loop. Provided they haven't entered the empty string, we convert the value to a float. We add the float to our, we add this new value to our running total, and update our total variable, and then ask for another value. Let's say at this point they enter the empty string. While the empty string does not equal the empty string, this would give us false, and we'd exit the while loop. Okay, so what this program is doing is allowing the user to enter values over and over and over again, keeping a running total of the summation of what we've entered, and will exit the while loop when you enter a empty string. Okay, again, you might want to pause the video, copy it down, give it a go, enter a bunch of numbers, and maybe enter the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then maybe at the very end, like outside your while loop, you can get it to print the total. That total should be 55. Okay, and remember that when you want to exit the loop, you type in an empty string, which is just no characters at all. Okay, so summing values is useful, and it's useful in other applications as well. So another application where we're going to use the sum of values is actually when we work out the average. This is kind of similar to the thing that we looked at near the start of this session. So we've got our total variable, which we initialize outside the loop. We've got our count variable, which is going to keep track of how many values we've actually entered. We have our priming read, so we get the user to input a value. Whilst the inputted value is not the empty string, convert the value to a float, do the summation, so this is this step here, right? Calculating the sum of the values, increment the count, so we know that we've added in a new value, we need the total number of values that have been added to work out our average, and then ask for another input. Okay, and then this loops back here, provided we haven't entered the empty string, convert the value that we've just entered, which is called input string, into a float, store it in the variable called value, add it to our running total, increase the count by 1 to indicate that we've added another value, and then ask for another input. Okay, this repeats until we enter the Sentinel value, which is this empty string, at which point our while loop exits because we get a false here. And we move on to the next line of code, which is the if count is greater than 0. So make sure that we're not doing a divide by 0. Okay, check count for 0, just to make sure that we don't do a divide by 0 error. If count is greater than 0, the average is our total, our running summation, divided by the number of times we added values to the total. Otherwise, the average is set to 0 because we haven't entered any data. Okay, so these are two super common uses of using loops. If I was thinking as a student, I'd be thinking about maybe working out my average grade. So I'd sum up, my exam scores, and then I'd divide by the number of exams I'd sat if they all had equal weighting, and that could give me an indication of what grade I'm on, which would be quite useful. You could do it with other things like attendance or, salary, lots and lots of different places where we use and calculate averages. Excuse me. Another example, so this is example 2, is counting matches. So let's say we wanted to check how many times a data set has a negative value in it. Okay, so we initialize the number of negatives we have to 0. We get an input from the user. Whilst the input is not the empty string, convert the value into an integer. If the value is negative, hey, we've got a negative value in our data set. So increase the number of negatives in our data set by 1, right? We're counting the number of negatives. We didn't have any. The first one appears and we increment our negatives from 0 to 1. And then we ask the user to enter a new value. Okay, they enter a new value. Provided it's not the empty string, we enter the loop again. Value equals input string. So we convert the input string into an integer. We check if that value is less than 0. If it's less than 0, hey, there's another negative in our data set. So we increment our negatives. Okay, eventually we reach the end of the data set. The user can indicate this by entering a empty string. when they enter the empty string on this line, we loop back to the start of the while loop, the condition becomes false, so we exit the loop and move on to the next line of code, which is print. There were the values stored in the variable negatives, negative values. Okay, so the way this works for counting matches to something is to initialize what your count variable, in this case negatives, the number of negatives, outside the loop. And then inside the loop, you do the check to see whether or not the value that you've just had entered from the data set meets the condition that you're checking for. Is it a negative number? If it is a negative number, increment the count of the negative numbers. Eventually, you reach the end of your data set, the user enters an empty string, and then you can print out how many negative values there were. If you're in a school and you're doing this, maybe you want to do it with grades, so you're actually checking how many A's your students get, or how many A stars your students get, or how many grade, 7 or highers if they've changed to that now. And you could do that by having, a count outside, and then inside, you're just checking whether or not the value is greater than a certain thing, or whether or not it equals A star, right? So you're keeping a running total. Okay, and then you can, put that on your website of, 90% of our students get A stars, or whatever it is that the school wants to publicize. Okay, so this is a really nice way of counting matches from a data set. Okay, the third example that we had is actually prompting until a match is found. And the way we like to do this is by using a Boolean flag. So we're going to set our Boolean flag to false. This is called valid. Maybe you could type it as not found, or found equals false. While not valid, while we haven't found our value that we're searching for, or we're trying to match to, get the user to enter an input. Okay, so this example is, please enter a positive value less than 100. If the value is greater than 0, so it's positive, and the value is less than 100, then we change our valid to true. They have entered a valid input. Otherwise, print invalid input. So if they entered something like 200, this is 200 is not less than 100, so we don't do the if condition, we do the else condition, which prints invalid input. We loop back to at the start of our while loop. We haven't changed the value of valid, so not valid is still true. We get the user to enter a new value. Okay, and this can repeat and repeat and repeat until at some point, hopefully, the user enters a valid input, a number that is positive and less than 100. Say they enter 67. If 67 is greater than 0, which it is, and 67 is less than 100, which it is, we switch our flag from false to true. So valid equals true. We go to the start of our while loop. While not valid, well, valid is now true, so not true is false. So while false, this exits the while loop and runs the next line of code. Okay, so this is really useful if we're searching for a specific piece of data in a data set to check if it exists. Maybe we're checking to see if any students have failed, right? And maybe we can go through our list and check until if the failing boundary is something like a 40, whether or not the students have got less than that 40 value. Okay, and when that happens, we return true and we exit the loop and we know someone has failed our exam. And then we have to write a reset exam, which is really annoying. So we initialize the Boolean flag to false outside our loop, and then test the flag in the while loop. So test the flag here. Get some input, compare it to whatever we're trying to do, so comparing it to a range, comparing it to a grade value, whatever. If the input is in that range, flip our flag from false to true, and the loop will stop executing. Okay, so that was example number 3. Example number 4 was maximum and minimum. They've kind of overlapped each other here. They're very, very similar. So the first thing you want to do is get your input value. This is either going to be this is going to be the largest and the smallest value you've seen so far. If you've only seen one number, it is both the smallest and the largest simultaneously, which is very interesting. You then get the user to enter a new value, but you store it in a different input, right? So input string. Whilst the input string is non-negative, is not the empty string, convert that value into an integer and compare it to your largest / smallest, right? We're going to look at largest first for the maximum value. So compare the input value to the current largest value you have stored. If the value that you just had inputted is bigger than your largest value you've ever had input, this new inputted value is now the largest value you've ever had input, and then you ask for another input string. Okay, so the user can enter numbers and numbers and numbers and numbers and numbers over and over and over again. If the inputted value is larger than any of the other values that we've ever seen, it's larger than the largest value that we've ever seen before, we update our largest value to be this new inputted value, and then we ask the user for another input string. Okay, at some point, hopefully the user will enter the empty string and will exit the loop, and the value stored in our largest variable will be the maximum value that's been entered. If you compare the maximum code, which is this box, with the minimum code, you'll see that they're very, very similar, apart from instead of having a variable called largest, we have a variable called smallest, and instead of having a greater than symbol, we have a less than symbol. Okay, so the first value that's entered is going to be our smallest value because it's the only value we have entered. We then get the user to enter a new value. Whilst that new value is not the empty string, convert the value into an integer. If the new inputted value is smaller than our smallest value, it now becomes the new smallest value. Right? Our smallest value is now the newly inputted value, and then we ask for a new input from the user and loop back to the start of our while loop. This repeats over and over and over and over again. Every time we enter a smaller value than the previous most small value, the smallest value we'd ever seen before, we update our smallest value to be this new inputted value, and then we continue with our loop. At some point, hopefully the user enters the empty string, and we exit the while loop. Okay, so part 1, get the first input value. This is the largest or smallest that you've ever seen so far. Loop while you have a valid number, so the non-sentinel value, which is not the empty string. Get another value. Compare the new input to the largest variable or the smallest variable. Update the largest or smallest variable if necessary. Okay, maximum and minimums are really, really useful. If you're trying to find, again, if we're talking about students and grades, if you're trying to find maybe the smartest student in the class or the student who gets the best grades in the class, you want to use a maximum function. If you're trying to find the student who needs the most help maybe in the class or whose grades aren't doing too great, you could use the minimum function. And you'd write a program like this. Okay, the last example that we're going to look at is comparing adjacent values. Okay, so the user is entering values over and over and over again, and we want to compare position 1 with position 2, position 2 with position 3, position 3 with position 4, position 4 with position 5, right? The values on basically either side of it. The way we do this is we get our first input value. This is our first thing in our list of values, and we store that in a variable called value. We get our second input, and we store that in a variable called input string. Whilst the input string is our non-sentinel value, so whilst we still have data to enter, we create a variable called previous, and we store in that previous variable the first value we entered, right? This one outside the loop. Okay, this is for the first time through the loop. We then set our value variable to be the input in an integer format. Okay, so the first value that we entered is now being stored in previous. The second value we entered is now being stored in value, and we do maybe some comparison. So we check whether or not they're the same value. If they're the same value, we print that there's a duplicate input, and then we ask the user for a new input, right, which we store in input string. Okay, so that was for entry 1 is now in previous, entry 2 is now in value, and entry 3 is in something called input string. Okay, we loop back to the start. Provided we haven't entered a sentinel value, our previous variable now is set to the value stored in value, which is actually the second thing we input. Value is set to the integer, the input string converted to an integer, which is actually our third value, and then we compare value and previous. Okay, and then print duplicate input. Okay, this one is definitely more confusing to explain, and definitely becomes a lot clearer if you take out a trace table, you draw the columns, you write down value, input string, and previous, and slowly input values into it, and cross out the lines as you go through, run through it by hand with a paperclip. Okay. Also, pause the video and maybe write down the previous pieces of code that we've looked at. So, both the sum and average example, the counting matches example, the prompt until a match is found example, maximum and minimum examples, and then comparing adjacent values. Run them and just enter values to make sure that they work the way you think they do. Okay, so the way this one works is we get our first value, use a while loop to determine if there are more values to check, making sure that we haven't hit the end of our data set, copy the input to the previous value, get the next value into an input variable, compare the input to the previous value, and output if they're the same. Right, this is what this print duplicate input line is for. Okay, so of the 5 examples, I think probably maximum and minimum as well as comparing adjacent values are the most confusing. So those are probably the ones that you'd want to spend the most time working through, again, probably with a trace table. Okay, to kind of help us with all of our problems, we're going to use something called a storyboard. So one really useful problem-solving technique is the use of storyboards to model user interaction. A storyboard can help us answer what information is the user going to be providing, and in what order are they going to provide that information. What information will our program display to the user, and what format will that display take? What should happen if there's an error, and what should happen when the program quits? Or when does the program quit? A storyboard consists of annotated sketches for each step in an action sequence. So this is going to be a little bit different to the storyboards, maybe if you've thought about, writing a film or a play or a book, right? You might have storyboarded designs. These storyboards are slightly different, but they have kind of similar ideas behind them. Okay, so our goal here is to convert a sequence of values, and we're going to need a loop and some variables. We're going to handle one conversion each time through the loop. Okay, so this kind of initial storyboard tells us what unit, we're going to print this to the user, what unit do they want to convert from? So they want to convert from centimeters. What unit do you want to convert to? They want to convert to inches. Okay, enter values terminated by a 0, so this is going to be printed to the user. They know what the Sentinel value is, and they're allowed to convert, to do multiple conversions, right? So 30, they enter the value 30, which is they're entering it in centimeters, and they're told that 30 centimeters is 11.81 inches. This format's really nice because it makes it clear what got converted to what. They didn't enter a 0 value, so we allowed them to enter a new value. They enter the value 100. Again, really nice format. 100 centimeters is 39.37 inches. Okay, they didn't enter the 0 value, so we allowed them to enter a new value. They enter 0. This is our Sentinel value. So we stop doing this conversion from centimeters to inches, and we ask them again, what unit do you want to convert from? Right, so we're kind of back at this stage of our program. So what could go wrong? Well, if we look at the storyboard here, the user doesn't actually know the full list of units that they're allowed to do, right? Allowed to convert from, right? We know maybe from this example that they're allowed to use centimeters and inches, but it's good to tell the user what possible conversion values they're allowed to use, right? So what conversions are available, but then also we have a problem of, hey, well, how are they going to spell centimeters, right? Maybe they're going to make a spelling mistake. What's going to happen if they make a spelling mistake? How are they going to spell inches? Maybe I don't know how to spell, tablespoon, or maybe I don't know that TSP is teaspoon and TBSP is tablespoon, right? So one of the nice things that we can do in our storyboard to change this is to show them the list of units that they're allowed to use, right? They're allowed to use inches, they're allowed to use feet, they're allowed to use miles, millimeters, centimeters, meters, kilometers, ounces, pounds, grams, kilograms, teaspoons, tablespoons, pints, and gallons. Okay? We list out, when we print information to the user, the valid units that they're allowed to use, and then they pick one, right? In the second line, we don't really need to print out all of the valid units that they can use because it's literally the line above, and hopefully they can just look up a little bit. Okay, what else could go wrong? Well, how does the user quit the program? If we look at the initial storyboard, we know how they can quit a single conversion, right? They enter a value 0, but then it loops back to the what unit do you want to convert from, right? So we can exit the specific conversion we're doing, but we haven't given them an option, or we haven't told them how to exit the program. So what we could do is after they've entered a 0, so they've stopped converting from centimeters to inches, we hit them with the prompt of, do you have any more conversions, right? With another Sentinel value, the Sentinel value of n exiting the system, right? Yes means we loop back and we allow them to enter one unit type to another unit type. If they enter no, we exit the program. Okay, so storyboarding and kind of writing out what your code should do, thinking about these questions can really help in identifying problems with the design of your code and the design of the problem you're trying to solve, and really considering user interaction. Now, this is quite a complicated use of loops. The Sentinel value stuff is a little bit complicated, so definitely take your time with this video. You might have to pause it, you might have to rewind it. If you go and solve some of the tasks as well, that will definitely help. And again, I'm not going to stop talking about it, but writing out a trace table will definitely help by showing you, how to keep track of variables. And by keeping track of variables, you're more likely to understand how the programs are working. Anyway, that's the end of session 7. I hope it was useful. We will see you in session 8 or in the problem tasks for session 7.